Okay, so let's take a look at 8a here. I've had a lot of you asking me about this. What you want to remember with 8a is that you want to try and get the radical all by itself on one side, so that when you square it, your life is just a lot easier. You don't want to square a binomial with a radical in it. It's just going to be more work. So what I'm suggesting is getting rid of this 5, so by subtracting 5 both sides. So you're going to end up with root 3x minus 5 all by itself on the left, and then you're going to have x minus 5. Okay? So when you get this root sign all by itself, the radical all by itself on one side, that's great. That's a good time to square both sides. So I'm going to now square both sides, remembering that when you square a root, that's just 3x minus 5. Whatever's underneath there is now liberated from that. Please do not do this. Please do not do this. This is not correct. You cannot just square each term. It's a binomial. You have to square this x minus 5 times itself, right? So it's really like this. Do FOIL. X squared minus 5x is minus 10x. Minus 5 times minus 5 is plus 25. So now you've got no more radicals. You're going to gather all the like terms onto one side of the equation, because you're going to end up with a quadratic, because you've got a squared. That's going to be by itself. So let's subtract 3x. Let's add 5 to both sides. That's going to get rid of these. You're going to have 0 on this side. It's going to be x squared minus 13x plus 30. Now, if you want to try and factor that and use the zero product principle, you got to think of factors of 30 that add to, is that right? Negative 13? Yeah. Okay, I think I saw somebody's work that had a 7 here. It's not 7, it's going to be 13, right? Yeah, I think that was mine. Okay, I missed that error. Anyways, yeah, it should be negative 13. So, yeah, so you can actually factor this one. It looks like pretty easy. X and x here, and then negative 10 and negative 3, right? Because that multiplies to positive 30, adds to negative 13. So if you can factor that, zero product principle says that this statement is going to be true when one or both of the factors equals 0. So let them both equal 0 and solve for x. So you get a possible answer of x equals 10 and a possible answer of x equals 3. And before you say, hey, I'm done, you need to check, okay? Because when we square stuff, we might be introducing extraneous roots, just the way math works. When you square something, the positives and negatives kind of go away a little bit. And so you have to go back and check your original question. So I'm going to check both of these real quick. 5 plus root 3 times 10 minus 5 equals 10. Let's see if that works. That's 5 plus root 30 minus 5, or root 25 equals 10. That's 5 plus 5 equals 10. That's good. Let's check 3. Okay. So 3 times 3 in there equals 3. So that's 9 minus 5 is 4. So 5 plus root 4 equals 3. 5 plus 2 equals 3. Ouch. So see, when we squared, this whole positive kind of became a tricky spot there. So yeah, so that's why you check. This does not equal. So it looks like we can reject 3. X equals 10 is your only possible solution. One more way I will show that you could look at determining or checking. So one of the other ways you could check, you could do it mathematically like I did over here, or you could graph the left side of your original equation as a y equals graph, and then graph the right side as a y equals graph, like I did over here in Desmos. And I'll maybe bring this over a bit so you can see. And so when I graph those two, right, what do I get? I get an intersection point. I only get one intersection point. And that one intersection point represents the solution to this equation. So the x value of the intersection point is my answer. Notice that, what was the other one? Possible answer was 3, right? 3. Okay, so if I go to x equals 3, there's x equals 3. Look at that. It does not intersect. And it would intersect if this parabola, or this other half of this parabola existed. See, this would dip down over here. So it would intersect if this red curve actually extended here. It stops because this radical, okay, the actual graph or the outpouring or the expression of this is only the principal square root. It's not plus or minus. It's only positive. If it was -2, it would dip down under here and intersect twice. But this, in the question, the way it's stated here, this is the principal root that we are dealing with only, not both possible positive and negative roots. Yeah, that's the tricky thing. I mean, yeah. Probably took me about 15 years to understand that teaching, so don't worry about it if you don't get it now. So that's why we check. Hey, bottom line, that's why we check. Okay? Any questions?